Okay, welcome to the first practical session. Today I'm here with Tanja, and this semester I'll only be here with Tanja because Michael is no longer working with us. So yeah, let's get right into it. What will we do today? Today we'll just do some basic stuff with vector classes and also show you the debugger for C++. We won't be able to cover everything you did in the lectures up until now, but that's why we have this now here on Tuesdays and then also on Thursday. Okay, maybe just because the kickoff was some time ago, here in the practicals, we will just do some, basically what's shown in the lecture, but we'll do more live coding and show you how you actually can implement this stuff that you learn in the lecture. And also we'll try to go a bit more in depth on some things you need for the assignments as opposed to the lecture. And of course, we also have more time for you to ask questions. So yeah, that's what we do in the practicals. And we also have the first homework already. I think the lecture team already announced that. Yes, it's in the Teach Center, quite similar to the weekly exercises in ISP, and the deadline is next week on Wednesday.
Right, so then let's get started with our first topic for today. So you've already had a couple of lectures telling you about all the basics of C++, and we'll also start off quite basic today in terms of that we'll just start writing some classes and get into the practical things that you've only heard in theory until now. And in order to do that, we will start off with a very small class for an ingredient. So we have a small diagram here, what we want there to be in this class. So we want an ingredient to be made up of a name, a unit, and an amount. And we're going to have to write a constructor for that in order to actually construct our object. And we will also add a print method to that just so we can print all these components of the ingredient class in a structured manner.
Yeah, and I think you already saw a diagram similar to this in the lecture. I don't know how deep they went into this sort of thing, but yeah, just the minus here means that we want to have these as private members, and the plus here means that we want this constructor and this method to be public in the class. Yeah, but more on that later.
Right, so let's get started with that right away. All of this stuff is going to be kind of big. Is that? Yeah, I think that's visible enough for everybody. Right, so all we have here so far is just a regular main.cpp file where we just have this main function, and now we want to implement this ingredient class. So what we need to start off with first is actually defining the class. So we will just use the class keyword here and call our class ingredient, just like this. And then you have learned in a lecture that in a class we can make certain things private and certain things public. So in order to protect the data members that we want to set for our class from being modified from the outside in an uncontrolled way, we will set these to private. So that means here we can now define our name, our unit, and our amount. For the name, we can use a very convenient thing as opposed to regular C, just the string data type. We don't need to screw around with char pointers in particular here anymore. We can already use a data type that we have for that. So that is going to be our name attribute. Then we want to make something for the unit, which we will do in a second. And for the amount, we will just make a double here so it's big enough. Right, so for the unit, we kind of want like custom values, because if you think of a unit in terms of ingredients, we have stuff like grams, we have stuff like milliliters. There's different types of units that we can use there, depending on what the ingredient actually is. So in order to make a custom definition for that, we can use something that's also new in C++, an enum class, which is quite convenient as opposed to the regular enums that we had, because we don't need any type def stuff anymore. And yeah, we also have the scoping of the enum class itself, and we will call that unit right here. We will go into the scoping in a second, but let's just define some unit types that we have here. So what did we say? We have gram, for example. We have milliliters. Did I spell that correctly? Yeah, I think so.
No, you have an E here.
Am I stupid? Yeah, I'm stupid. Never mind. Whoops. Then something like a teaspoon. And yeah, maybe we can also do something like just a regular unit in case we don't really have anything else set, right? And then we can use this already down here and make one of our members already of this enum class that we've defined up here a unit, just like this.
Yeah, up until now, these enums seemed very similar to the ones we defined in C.
Right, so those are our private members. So then for public things, we want to be able to construct our object, first of all, which is why we need a constructor, which we will just define just with the class name right here, and also the arguments that we want to pass to this, which we need to construct our object. So in our case, we can just say we pass everything to this constructor. So we want to give it a name, we want to give it a unit, and we want to give it an amount, just like this. And then we also learned, oh, whoops. That was not the right key for that. I wanted to make it smaller, but it's a bit big, I think, right? The text, Julia? Is the text too big?
I think it's fine.
Oh, it's fine, okay. We heard about something very convenient in a lecture as well, which is an initialization list, which we can use right here to directly assign these three perimeters that we're passing here to our three objects up here. So we can just do that like this. So you always need to do first the attribute that you want to assign something to, and then the actual value that you want to put in there. And then we can just list that like this in this initialization list. So we can do that for unit as well, and for the amount as well, just like that. And then we just can't forget the function body back here, because the constructor still is essentially a function, and you could do something in here, but in our case we have a very simple class here where we basically just need to pass these three perimeters and assign them here. But if you had to do some complex operation or something in order to construct your object, you could do this in here.
Maybe put the initialization in the next line.
Yeah, I think that's probably better visible in this resolution.
Yeah,
yeah,
so
that's better.
The actual construction in the initialization list is the exact same as when you just create a variable that you want to call the same as this member. We'll see this in the main really soon, but I think this was also done enough times in the lecture. So yeah.
Yeah, so basically now we have the basic construction of our class figured out. So now we can, for example, start down here and actually construct an object. So we want to make an ingredient, and we can just call this salt, for example. And then we will pass it our three perimeters, which are going to be the name salt. Then the unit we want for this, so we could just say, and this is where the scoping becomes important. We could say gram here, for example. And as you can see here, we can directly specify that we want the gram that is from the unit enum class. Why is this important? Because it basically the scoping avoids if you have, for example, a different unit class or something else where gram as a member would make sense. You can differentiate those through the scoping. So we just have more type safety here, basically.
Yeah, also in C, if you have used many enums in ISP, you might have noticed that really the enum members that we have there just behave very similar as if this would just be any constant global variables that you have, such that if you use them, you just need to specify the name. And if you have many enums, it can be confusing which enum belongs to which. And also, I do not think that the compiler really throws an error if you pass the wrong enum value to the wrong enum type. But here in C++, we can just always enforce that we specify that we actually want the unit enum.
Right, so now we have our first ingredient here, and let's just try to print that out as a first step.
Just one more thing.
Yeah.
Here you use these curly braces for the constructor, and up in the initialization list you use the round parentheses to construct those things, and you can use both to call the constructor. So basically the curly ones just provide a bit more type checking that you actually pass the correct things. But we won't go into the details now, just so that you don't get confused. You can use both for calling the constructor.
So then we will try to print our salt just to see what we have here. So we can just say, and we will try to do this now in a way where we will fix it in a second, but so here we're just using the outstream operator and just chaining these together in order to print the string here. And we want to, you can already see that there's some problems because there's a red squiggly line, which is on purpose. Right, so it doesn't allow us to actually directly access name or amount like this. If we just hover over this for a second, we can see that the member ingredient name is inaccessible. Why is that the case? Because we made it private up here. So this is exactly what we're preventing by making these members private instead of public, that someone can just call them like this from outside of any class context. So what we can do in order to make these visible to other classes is in order to make a getter or a setter if we want to actually get the values or we want to update the values accordingly. So in this case, we want to just retrieve the values of name and amount. So we can just write getters for that. So we can just write here a function called getName. We don't need any parameters here. And then we can just say return the name, which is possible here because we are within the class context, right? So here we don't get an error that this isn't possible. And here we're going to do get amount. Oops. And we can just do that right here. What we can also do here, which you've also heard in the lecture already, is that in front of this function body, we can put a keyword, namely const. Const in this case basically means that we're promising the compiler, okay, whatever we do in here in this function body, it's not going to modify the object in any way, which also stays true here because all we're doing is just taking a value from in here and returning it. So we can do that for both of these. And this is generally something that you can do with getters, because in a getter, you never want to actually modify the object. If you do want to modify the object, it's probably not a getter.
Yeah, and by modifying the object, we just mean the ingredient that we are calling this method on right now. So we have some ingredient dot get amount, and the object that we can't modify then is the ingredient. So inside of this get amount, we couldn't do, for example, name equals something else, because if we write this as const here, we can't modify name or amount or unit inside of the function. Maybe another question here that you could have is, why would you even write these getters instead of directly accessing the private members? Well, the idea behind this is that the way your class works shouldn't be somehow observable from the outside, because from the outside you just call get amount, and how you get to this amount shouldn't matter. And if at some point you decide, okay, I do not want to store the amount directly, but or I want to call it differently, then you can just change your private members around any way you want, fix the stuff inside of your class, and from the outside you just have the same get amount method.
So now that we have our getters, we can update how we wanted to access the attributes down here. So we can just use getName here directly in this cout statement. And the same goes here for getAmount. And this should already work. So now we can try compiling for the first time, because I'm not entirely sure if that's been in the lecture already. We use clang++ to compile, and then we just mention the CPP files that we actually want to compile. And just like we had with compilation in C, we can specify a -o again, and what we want the executable to be called. So we can just do that. So now we have a main executable, and all that does is it prints us salt with the amount 5, which is what we specified up here. Right, so the last thing we wanted to do for now was also define a print function for the entire ingredient. So we're also going to make this public so we can use it outside. So we're just going to call this print. We can make that const as well because we just want to print some things. And we're just going to, oh, forgot that. And we're just going to do some prints in here. So first of all, we can say, we just do sort of a list appearance here. And then like a space here, for example. And then we want each of the different unit types that we have to be printed a certain way so we can actually differentiate between them. So for that, we can just make a little switch case with the unit member that we have. Then we need to make a case for each of the ones that we have. So for example, for gram, we want to just do a G like this. Then just another. This is just going to be a little bit of typing. Then for milliliter, we want this ml string, for example.
I mean, you do not need to implement all of them.
We have the time, I think. We have the time. I'm almost done, so. I want to do TSP here for teaspoon. And last one. The unit itself. So in case we just say we have units of something, we can just do the string unit and break out like this. That's the switch case. And then as a final thing, we want to just say that the string so far would just be name, grams of, oh wait, I switched these around.
Yeah, so we want, for
5
example,
grams of salt.
Yeah, 10 grams of
something. Right. Mm-hmm. So then we can just try to call this down here instead. So we can just do salt.print, which would access exactly this print method that we just defined. Yeah, and here we can see 5 grams of salt, like this. So this is just a nicer way now of printing our entire ingredient without us having to do some type of printing logic actually outside of the class. So we can just outsource all of this just into a method of the class itself. And for example, if we wanted to update something like the amount now too, we can also define a setter for that. So we've only done getters until now. But we could, for example, also do something like set amount.
Yeah, of course, for the same reason, because we can, from the outside, change the amount of an ingredient. We need the set amount.
But in this case, we wouldn't make that const now because we are actively updating something.
Yeah, so this is here the difference if you write const after the function header. If we, for example, here we change the amount. And the amount is a member of the ingredient. And if we write const there, we say we do not change the ingredient. So we cannot write const here.
So now just to see the difference, we could change the amount here before we do the second print, change it to 10 instead of 5. Then we compile one more time, execute one more time, and now we can see here, up here in the simple print, we still have 5, and down here we have 10 grams of salt. Yeah. Right, so then we can switch over to here.
So, of course, if we have ingredients, the thing we want to do is put them in a list. So we want to have multiple ingredients for some, I don't know, maybe for a shopping list or a recipe. Therefore, we'll recap the vector. You heard of the vector already in the lecture, but it's really an upgrade to the standard C array. Because, for example, here we see the first two things. If we define a vector like this, like any other type here, we just specify the type. We need to write the type, what the vector we have in here, in these angled brackets, the integer. You will see what this does later on in the course. And then here, we can just call the constructor of the vector with some integers. And then afterwards, opposed to the array in C, we can, with the size function, just get the size of a vector. Or we can just add an element with pushback method to the end of the vector. And this will just sort of like, if you in C, you would do a realloc and then put the element in the back. And this pushback on this vector just does everything for us. And you do not need to worry about if there is enough memory or something. Then how do we access element? We still have a few things in here from testing. If you have such a vector, then, for example, you can access the first element with the add method on the vector. You could also do it just like an array. This also works. If we run this, we see we get 0, the first element. But I would recommend you to always use the add method when accessing elements of a vector, because when you use the add method, I mean, if it works, it's the same. But if you use the add method, the advantage is that if you try to access an index outside of the vector, so we have here 3 elements, and if I want to access the 4th one, then we do get some kind of error when you try to execute it. And you do not get this with the, if you do not use the add method. Therefore, I just would use it so you spot your mistakes immediately. Okay, then let's continue with making a vector of ingredients. I think, wait. Yeah, I think I'll remove this. So, how do we create a vector? Well,
oh, right, sorry. I forgot switching.
Now we do not want integers, but ingredients. And then we can do something like this, and we then here also call the constructor of the vector. And in here, we can put some ingredients. The thing is, why all of this is red is because we did not include the vector yet. Maybe I'll do it a bit smaller. So what I'll do is I'll include the vector so we can use it. Okay, so everything seems fine. Now, how do we create ingredients? Well, in here, we can just to create an ingredient. Of course, we can do something like this. Maybe I shouldn't have deleted it, but if we have some salt here with the unit gram and, I don't know, 10 grams, of course, we can just write this variable in here. And now this is a call to the constructor. The constructor of the vector just takes an arbitrary amount of elements we want to have in the vector. But what you also do is you could theoretically directly in here, I don't know, maybe sugar, construct the ingredient. Or maybe teaspoon, 1 teaspoon. And maybe some third thing, because we want to loop over this, maybe some apples. And now we just get 2 apples. Something like this. Yeah, maybe just some cool thing now, because C++ already knows what type we have in here. We can also omit naming the constructor we want to call, because it knows we have a list of ingredients. Therefore, this can only be the constructor call. But I'll add it back so we not get confused. So how do we loop over such a vector now? Well, of course, we can do it just like in C, where we say, okay, we loop over the, wait, I called it ingredient, I wanted to call it ingredients. We loop over the ingredients up until size, we increment our counter, and then we do ingredients.add_i.print, for example. We could do this, try to compile it, execute it, and we see, okay, all of the things we did, that we put in the vector are now here. But now let's change something, maybe put in here, I don't know, anything.
Eggs
milk,
or something?
Okay, milk, okay, eggs, yeah, we can also do eggs. Then again, I think we would use units, and then 12 or something. Okay, now we added eggs. And in the lecture, you have seen these range-based for loops. And this is really a better way to write this, because this, I mean, okay, you've seen this 100 times now, so you look at this and immediately know what's going on. But what you can do is, so ingredient in ingredients, you do something like for each ingredient in my ingredients vector. And now we directly get, we do not need any index or something, we directly get the ingredient in here. We can do ingredient.print. So here we create the ingredient variable kind of and say, okay, we want in this for loop this ingredient to be each of these ingredients that we have in the list. And if we can execute it, we can see that we get, yeah, here's the second list now also with eggs.
Now, could we just modify the list in here?
Yes. So this is the second thing. If we now try to do something in here, for example, ingredient.setAmount, maybe we want to set the amount to 0 before we print it. So we want to more or less undo all of the amounts, and okay, seems to work. Everything is 0. But what happens if we try to print this now again? Now if we print the list for a third time, so here we call the set amount for each ingredient, maybe let's do something like this. We, instead of setting the amount to 0 and printing, we first loop over all ingredients, set the amount to 0, and then we try again to print all ingredients. We can say that it did not work, because here we again have all those units, but we wanted to set them to 0. Does anyone have an idea why this could be the case? Yes? Yes. Exactly. what we are doing here is just like maybe imagine writing something like ingredient, no, I wanted to have it like this, equals ingredients, and then add some index. And because it happens something like this here, we are creating a copy. So this is just like in C, if we have a struct and we assign it, or we have an integer and we assign it, we are creating a copy. What do we want to do if we actually want to change something? Well, you know this from C already, then we, of course, could use a pointer, or something that is new in C++, we can just write a reference here. So now we have a reference to an ingredient, and now if we change a reference, it of course changes at the place where we have it, where it's stored. And now we can see we actually set the units or the amount of those ingredients to 0. Yeah, and of course here in this pushback, again, theoretically you do not need to write this ingredient. You can just write the constructor directly like this. Okay, so
maybe quick question to the audience. Are there any questions about what we've done so far? Anything that was unclear maybe? Okay, doesn't seem to be the case. So then we can continue with just really quick showing you how we can set up the debugger and actually use it now with C++. So what we use here is, I do believe this is the same one as in ISP as well, the VS Code extension code LLDB. And basically, yeah, there will be a launch.json file, which we just need to update to actually target like the path of our binary executable. And then we can set breakpoints wherever we want to actually watch the values and how they change over the course of the program. So we're just going to do that right here. First, I just need to delete the test one. Oops. Right, so we haven't set that up yet, right? So in order to do that, we just need to go here to run and debug. And we start run and debug. As maybe first thing would be to install here the code LLDB extension, which I have already done, which is this one. Right, and then we can just go over here, click on run and debug. We select code LLDB up here. Then we get this launch.json that we were just referring to, and then we need to specify the path to our binary file, which in our case right here would be, whoops. Just gonna switch back to that again. Which this is just the path to our file here. So whatever your path is going to be, you need to make sure that it's the correct one. And we do have that compiled right now. So what we can do now is we set, where do we want to set a breakpoint? For example, we just put one right here, for example, with the set amount to 0. And maybe down here or something. And then we can just click here on launch and debug. Launch with the debugger. Oh, right. One important thing I just forgot. Does anyone remember from ISP why that did not work just now? Actually, it was a good demonstration effect. There was something crucial we forgot when compiling. Does anyone remember what we need for that? Yeah? The correct flag, right. So before we compiled with, if we go back to the correct terminal up here, with C++, just the name and -o main. But we cannot forget -g for the debug flags. If we forget that, it's not going to work, and it's not going to do anything like you just saw. So let's do that, and try that again, and suddenly it works. And now you can just see over here, the program stopped at the breakpoint I set right here. And then we can just see here with ingredients, we have size 4, and we can nicely, if I can get this, oh God. make this a little bit smaller so we can see something. And if we now just step over each of these, we can watch how the values update here. First one goes amount to 0. Then we have another amount to 0, and so on and so forth. So this is just how the debugger works. If we press the continue button, we can jump further down to our next breakpoint that we set down here. You're probably familiar with this already from ISP, but just in case you've forgotten, it works very similarly in C++, and you can very nicely watch all the values over here again. Right. So then we can switch over here again.
So, yeah, I think you already did this in the lecture, but just to recap, same as in C, why do we need multiple files? Well, we just, especially in C++, separate the functions from the class, because if you write all of these definitions, for example, here the print method inside of the class, it gets really long and easy to miss something. Therefore, we write just the function definitions inside of CPP files. We know that. And for the declarations, where we write the classes, we write those in HPP files. And most often, the best idea is to just write one class into one file, and then just include them for everywhere you need that class. Again, like in C, if you want to now compile multiple files, you just need to specify all CPP files. You do not need to specify the header files. Yeah, just the CPP files. Yeah.
Right, so let's see what that looks like with our ingredient class that we've already made. So just to make things a little bit quicker, we've already made 2 completely empty files over here, so we don't need to do that again. Right, so now we just need to split up the ingredient class that we have defined in here into these other files. So basically we can leave the main in here because we don't really need that over in the other files, or rather we don't want it to be in the other files. Right, so let's just, do we need the vector? No, that's only in the main. So we can just cut up to here and just completely cut that out. Of course, now everything's going to be red because the program is going to scream, oh no, I don't know what an ingredient is, but we will fix that in a second. So first of all, we need a header guard again, like we've also briefly discussed in ISP, I believe, just to ensure that a file can't be included multiple times. So we will just define that right here.
Or more like so that our file can be included multiple times. Just that it won't cause any errors.
Right. So we won't actually have any issues with that. Of course, we do need, although let's do that in the other one. Right. So now we have our header guard here. This stuff can stay, so we can already see. Okay, we need a string in here because we don't have the includes from the other file anymore. So we can just include string right here directly. And basically what we now want to do is to move all of the definitions, so something like the print function here would be a definition of the function, over to the CPP file, and only have the declarations of everything in here. So that means if we go over here, we would need to first include the ingredient.hpp file here, and then actually put our definitions here. So for the print function, this entire function body is our definition. We want this to be over in the other one. And this would just be our declaration. Just this void print const. We can already see the compiler or IntelliSense is warning us, oh, the function definition for print hasn't been found because we haven't put anything like that in the CPP file yet.
Yeah, and the syntax here is just like format declaration of functions in C.
So now we will just write it just exactly as we had in the HPP file. But there is one minor but very crucial difference if we put this in the CPP file, one thing that's very important that you must not forget for any method that belongs to a class is to actually scope it with the class right here in the CPP file. Because otherwise, basically things are going to, so to speak, explode a little bit. Because the linker is going to go crazy and say, hey, I can't find the print function of the ingredient class because we've just put, so to say, an arbitrary print function here. We haven't actually told the program, hey, this belongs to the ingredient class. This is exactly that print function, not any other type of print function. So it's important that we put that in here. And one thing we also want to show is that you can also directly include classes just in the CPP file. You don't need to do it in here in the HPP file. It's probably nice to have all of the includes in one place, just so, yeah, it's more structured and you know where to look, so to say. But you can also, for example, just include here. So we don't have anything included here that actually handles the cout. So we can just include IO stream right here. And that's also fine.
Yeah, sometimes you also have some issues if you have some headers that include each other. It's not always a problem, but sometimes, and then it could also help if you just include in the header as little as possible and the rest of the includes in the CPP file.
Yeah, and one thing that we should also put in the CPP file is probably the constructor. We just copy this right here. So here we can also say the initialization list is, so to say, like the definition. And we can just, if we erase that, we have the declaration right here. And then also up here, we can just put the constructor again. But just like with any other function, I know it looks a little bit weird, but you need to put the name of the class again before it to scope it. So you kind of have class name, scope with class name. That looks a little bit weird, but that's how it works. So.
Yeah, because otherwise it could just be a function that you want to call ingredient, but you actually want to define the constructor of that class.
Right, so that would be that split up. But then we have another idea of what we can do. We can also extend this a little bit further with a class for recipes, because we now have ingredients, but we don't really know, like, what are we going to do with ingredients, right? But what we can do with ingredients is we can cook them according to some recipe, which we can also turn into a class. So for that, we just have 2 additional files. First of all, I think we could fix this right here. So here in the main CPP, before I start writing recipe, we still have a lot of red stuff going on and squiggly lines because no one knows what an ingredient is or what a unit is. So all we need to do to fix that is just also include, and careful here, the ingredient HPP file, not the CPP one, but the ingredient HPP file right here. And everything works again. Let me just actually show that everything works again in the correct terminal if possible. Actually, let's show this as well. So this is what we compiled with so far. That will not work anymore because we now have more than one file. So what do we need to add to this? Yeah. Yeah, the wildcard, but just to keep it more, include both, yeah, exactly. So now in the front here, we can just put the ingredient.cpp, and then it's going to work again. And then we can see if our program from before still works. Yep, that still works. And then we can extend that with the recipe class. So here we need, once again, the header guards. And then we just want to assign a name to this and give it a vector for our ingredients. So just as we had, we're just going to write a class for that. And we're going to make some members private again, which will just be and a vector here with an ingredient, or with ingredients that we'll call ingredients. And here we need to be careful again because we need some includes. And here we can just start off right away with including our ingredient because we need that in order to use it here. Can just include the ingredient HPP again. And then we can already see that the string, the squiggly line, already went away because we are including string over here in the ingredient HPP file. And by including this HPP file itself, this include is also visible in the recipe class. So that means you don't need to include everything like twice, 3 times, 4 times, if you already have that in an included HPP file.
Yeah, quick recap from ISB. The include just copies the other file to this file. So here we just more or less copy the contents of ingredient.hpp into the recipe.hpp. And therefore, if we have the include of IO stream in the ingredient, it's then also in the recipe HPP.
Right, so here we also just want to have, once again, a constructor, which we're going to define over here in the CPP for the recipe, where we need to include the recipe HPP again. And we just need the constructor here one more time, which we can set with an initialization list again, like this. But we're just going to set the name here, because we're only going to push back stuff in the vector later on. All right, what else did we want in here? We have the constructor, set ingredient, and print.
Maybe a question for you. I think this was mentioned in the lecture. If we do not specify, for example, now the ingredients in the initialization list, now we just set the name. Do you know what happens with the ingredients vector? So, more specific, is there some constructor called for the ingredients vector? Is this member constructed? And which constructor is called? Yeah? Yes. So, yeah, all members, even if they're not in the initialization list, their constructors are called in C++, always. And if we do not specify anything in the initialization list, any constructor that we want to call, the default constructor is called. And the default constructor is just the name we have for the constructor without any arguments. And if we just have some class with only public members, for example, we automatically have a default constructor or for structs. Yeah, and the vector also has a default constructor that's called in this case, which just creates us an empty vector without any ingredients.
Right, so then we want to actually add stuff to this vector now. So we can just make a method for example, set ingredient, which doesn't directly set like the ingredients, but it adds something to them basically. Right.
Parameter.
Oh, right. We need an ingredient to add, obviously. That would make sense. And then we can just take that right here, add that over here. Don't forget the scoping. And then we can define down here that all we're going to do is just do ingredients dot pushback, so add something to the vector and the ingredient that we've passed as a parameter. So we're just adding ingredients to this ingredient list. And as a final function that we're going to define here, we just want to be able to print such a recipe again, which we can once again define as const, because we're not going to change anything. And same as before, we can just scope this and then somehow print our recipe. So we're just going to say something like, "Whoa, what did that do?" sorry, OOP recipe, or yeah, like that, and then we say name, and for example, a new line here. All right, we haven't included that, so we can just once again put here the IO stream include. And then we can use a range-based for loop again to iterate over our vector. And if we want to do it really, really nicely, in the sense that we don't want to change anything in this vector, we can also put const in front of what we put. And if we feel a little bit lazy and we don't really want to think about what's in this vector, we can also use a very convenient keyword, which you've heard in the lecture, called auto, which basically just assigns the data type as fit through the statement. And we put a reference here again. And we will still call this ingredient, but technically we're not saying that it's of type ingredient. And if we then put ingredients back here, which is the list that we have in our class, if we hover over this, it's still gonna notice that it's an ingredient. So as you can see, if we hover over the ingredient, despite the auto being in the front there, it still realizes this is a const ingredient reference. So less work for us. But do mind that you don't overuse the auto operator, because in some cases, it may happen that it assigns something that you didn't actually want, or it kind of obfuscates or just makes it a bit harder to track what you actually modify in what way where, or what data type you set something to. So it's still better to use data types themselves, but for something like this, for example, where it really doesn't matter that much, you can always use auto, for example. So in here, we can now just make use of the convenient print method that we already have in the ingredient, and just call ingredient.print. Right, so now we should probably have a look at this in the main. Let's put these breakpoints away. So we have a bunch of ingredients now.
Yeah,
I think I'll just, I was going to say, I'm just going to remove these here.
I'll remove this one.
Yeah. Now we can just, okay, actually, we can't define a recipe yet because we need to first include that again. Right here, and then we can define a recipe here, which, for example, we're going to call, I can't think of anything better, so we're going to do salad, and we will give that a name, salad, obviously. And then we can, we do have the ingredient salt here still. We can put salt into a salad. So now we can call our set ingredient method here on the ingredient that we set up here, the salt, and just add that to the recipe. What we can also do, though, is, just as we've seen before already, you can also just directly construct the ingredient right in here. We can put, I don't know, a tomato or something. And then just, I don't know, unit, and like, I don't know, 2 or something, which you can just put in here as well. And then we can, for example, print that with our nice print method that we've defined. Now, once again, we need to update the compilation command here, because we do also have the recipe.cpp file now. And that works perfectly. And right, so now we can see we've removed all of the other prints. So the only print we have now is this salad.print down here, which prints exactly the 2 ingredients that we've just added to this recipe. Yeah. So that is that. So how would we go about if we want to change an amount of something now?
Yes, so let's say, for example, we make another set ingredient. And I don't know. Maybe let's do sugar. I don't know. I wouldn't add this to a salad, but maybe you want to. And let's say maybe we do way too much sugar into the salad. And by accident, now we want to have less sugar. Well, that's the reason I call this set ingredient, so that afterwards, I want to be able to do something like this, where I just call set ingredient again, give it the same name, and then say, yeah, we do not want any sugar in our salad. And then I want to print it again. But of course, if we now do something like this, of course, this just adds a new ingredient with the same name. So what we now want to have if we have the same name already in the ingredients, we just want to override the amount. So how do we do this? Instead of just here calling pushback, we want to loop over the ingredients, and now I want to call this different. Yeah, this is the other ingredient. Now, if the ingredient, the name, we can actually directly access this. No, we can not directly access this. We need to call it a get name. Because we are not in the ingredient, we are in the recipe. We can only access things that are here in the recipe, not in the ingredient. And we can just now, in C, this already would be a problem, but here in C++, if we have an std string and not a char pointer, we can actually compare this with equal. So this does actually work. And now we want to override the other ingredient, which is the one in our ingredients list with the one we are setting. And then here, I don't know, we can then stop and return. Yeah, maybe we just want to replace the first ingredient. Okay, let's see if this works. Oh yeah, no, this won't work, but now we do not have any ingredients because, of course, we use the set ingredients in the main to add all our ingredients, and now we only replace ingredients. So, of course, we need to push back the ingredient if it's not already in there. So if we have this for loop, we loop over the ingredients. If the name is the same, we just override the ingredient we already have, return. And if we run through this for loop without ever returning, so without ever finding an ingredient of the same name, we add it to our ingredients list. Okay, now we at least have some ingredients in there, but it did not work. We again have 100 grams of sugar in our salad, but I wanted to have 0 grams.
So can anyone spot what the issue could be? Because we're looping over, we're updating stuff, but there's a crucial small difference once again.
So it also does not add the sugar for 0. So we do hit the return, because it does not add sugar with 0 grams. We actually go into this if, but somehow the amount is not overwritten. Yeah? Yeah, same mistake as before. The ingredient here is copied if we loop over the ingredients. What we need to do is actually just use a reference here to actually just get references of ingredients, because otherwise we are copying each ingredient out of the ingredient array and then modifying the copy, which does nothing. I would recommend always, if you use such a for loop, just write the reference there, and maybe also const if you do not want to modify it, just because then you don't need to actually copy all of the ingredients out of the vector. Always a good idea to work with references here, and then just make it const so you don't actually modify anything. And if you do want to modify it, as it already complains here, like we're doing here, then We do not need the const, but the reference.
This is especially important because this is such a small difference to kind of read over, which you can actually spend quite some time at the beginning just getting stuck on. And yeah, just don't start not using the reference. Just start with always using the reference and it'll be fine. Yeah.
So that's why we did this mistake twice, so that you're now already prepared for if you make this mistake. So now it works. If we do set, no, wrong file. If you do set ingredient again with the same name, it overrides how much you want to put in there. Yes, one more thing. Here, of course, what if you write auto? Is this now a reference? Is it not a reference? Let's test it. It's not a reference. So also if you write auto in this for loop, you can write a reference after auto so that you can actually modify this. And I think we can also, if you hover over this, we see here ingredient reference, and if we remove this, we just see ingredient, so it's again copied. One more thing, because we have the time. What you can actually do in C++, now this is a bit not that relevant to everything else we did up until now, but if we say, okay, we have this enum class unit, but it's only ever makes sense to use this within the ingredient and never anywhere else, we can actually I mean, we can define multiple public and private things, but we can actually here write this enum class within the ingredient. So it's kind of like the unit for the ingredient. And we have this in here. You can also do this with classes, but I would not recommend this, but maybe for enums it makes sense. Yeah, another thing I did here is that I did like public, private. Public, you can do this, of course, as often as you like, but how do we use this unit enum class now?
Maybe let's try to ask first, what do you think changes if we move the unit enum class into the ingredient, was it right?
No,
the ingredient. No. If we move it into the ingredient class, what do you think changes? If you think of how we defined methods for the ingredient class or classes in general. Yeah?
Yes. Yeah, we need to change the scopes. It already tells us this here that it cannot find a unit, because now this is not like at the top level, but in ingredient, and it's not like now a member of ingredient, so that we write ingredient gram. This also doesn't work. We need to write ingredient, so inside the ingredient, we have the unit enum, and inside of the unit, we have the gram. So, kind of similar to how namespaces works. No, wait, we have the unit here.
No, that's the unit of unit.
Oh, that's the unit of the unit.
That's kind of confusing, actually.
Yeah, if you think about what we did in the lecture, I think this was in the first lecture, where you talked about namespaces. If you put like this unit inside of a class, it's like it's in the namespace more or less of this class. So you have to specify that we have the ingredient where there's the unit, where we have the actual unit inside of this enum. Why does it replace this if I... Okay, like this. Okay, we also have this down here.
Are there any questions on that so far?
Yeah. So what did you do? We just looked into classes, in the very basics of classes in C++. I think this should be the first and the second lecture you had. We looked into the vector a bit more in depth. We also used the string. We also showed you the comparison of strings. We talked about constructors, and we also showed how you use the debugger. And yeah, as always, use the debugger if you have any issues. It's way nicer than doing printfs.
Yep.
So now, okay, do you have any last questions before we? Mm-hmm.
C++ 20.
Yeah, so which C++ standard should be used? C++ 20, as you said. Yeah, just like in, I think, I don't know which C standard we used in ISB, but yeah, we use C++ 20. Any other questions?
So if there aren't any other questions, then thank you for participating in the practicals today. We will see you again on Thursday for lecture and practicals, and also the release of A1. So make sure you pay attention to that. Make sure, you attend on Thursday again, and we wish you a great evening.